Hello guys, welcome to Careers 360 and this is our question for discussion. The question is the pressure exerted by an ideal gas is dash of the kinetic energy of all the molecules contained in a unit volume of a gas. So let's get started with the solution. See, you all know that internal energy, I'm writing the short form, internal energy is equal to the sum of potential energy plus kinetic energy. Now, first of all, I want to discuss about potential energy. See, my dear friends, potential energy in an ideal gas is assumed to be equal to zero. See, potential energy is associated with intermolecular forces and is presumed to be zero in an ideal gas, where the only molecular interactions are the perfectly elastic collision between the molecule. So, we can say that internal energy IE is equal to kinetic energy in an ideal gas. Now, internal energy is represented as E, which is equal to NCVT. Okay. Over here, CV, it means specific heat capacity at constant volume. So if we assume that the gas is monatomic gas, we can say that CV for a monatomic gas is equal to 3 by 2R. Now, if I substitute this particular expression in this equation, I will get E is equal to N into 3 by 2R into T. Clear? Which in turns become 3 by 2 nRT. For ideal gas, you all know that PV is equals to nRT. That means E will be equal to 3 by 2 PV. Okay. Now since E, which is internal energy, it is equal to kinetic energy. So I can say that kinetic energy is equal to 3 by 2 PV. Okay. So it means pressure P is equal to 2 by third of kinetic energy, where volume, as you know, it is a unit volume. So V is equals to 1 and the answer for this particular question is 2 by third. So we can say the pressure exerted by an ideal gas is 2 by third of kinetic energy of all the molecules contained in a unit volume of a gas. Thank you very much.